Welcome to Ceetron Analyzer. This first video will show you the general layout of this post-processor. The application window has a menu bar, several toolbars, a view where the model will be displayed, and a number of docking windows which can be shown or hidden. Let's open a model and take a closer look at these. The Windows menu lists them all and allows to toggle their visibility. First, there is the selection window. This window will display information on items picked on the model, such as nodes and elements. The top pane will show the list of items, and the bottom pane will provide information on the currently selected item in the list. Note that you need to click on Multi-Select to enable multiple selection. The next docking window is the workspace. The top pane contains the model's feature tree. This is where all of the model and view data is exposed, and where you will be able to configure the display by selecting results, adding cut planes, setting up animations, etc. The bottom pane will show the properties of the currently selected item in the feature tree, allowing you to specify this item according to your needs. The final docking window is the Python console. Ceetron Analyzer provides a Python interface which allows to interact with the model and view in this console, as well as defining custom results. By writing your own Python modules, you will be able to automate your workflow and gain efficiency. Now, let's have a look at the menu bar. The File menu is where to go to open model files, close them, or export data to various formats. This is also where you can exit the application if you don't like closing windows. The View menu exposes a number of options relative to the 3D view, navigation options, and view configuration. The Draw Style menu lists the available ways to display the model. You will find these options in the Draw Style toolbar as well, for quicker access. Note that the selected Draw Style option applies to all of the parts in the model. To specify a specific draw style for a given part, you will have to select it in the feature tree in the top pane of the Workspace window and select the draw style in the bottom pane. The Python menu simply allows to hide and show the console. This can also be achieved using the Python console toolbar button. We have already seen what the Windows menu offers: hide or show the application's docking windows and toolbars. The Help menu gives access to the application's log file, which is handy when something doesn't turn out as expected. Opening the About dialog provides version information and is also where you will find information about your license and how to manage it. This concludes the general presentation of Ceetron Analyzer's top-level graphical user interface layout. This video describes the use of the View item in the Workspace feature tree. When you select View in the feature tree, the bottom pane of the workspace displays the current view configuration and model information, its bounding box, the number of states, parts, and other data regarding elements and results. This is also where you are able to configure the view, setting its background color. Could be a single color, or you can apply a gradient. You can also set the color of the halo that is used to highlight selected parts. For example, setting it to black. You can also select what to use to color the model. By default, the model is colored according to parts. You can also use sets to color the model, or even element types. Finally, you can select to show or hide various overlay items in the view, such as the navigation cube, the state info text, or the description box. This video describes the use of the parts item in the workspace feature tree. Here is where all the parts found in the model are listed. In the tree, clicking on the eye icon next to a part or double-clicking on the part itself will toggle its visibility. Visibility also appears as a property of the selected part in the bottom pane of the workspace. In this pane, you can change the part color or its opacity using the opacity slider. You can also change the default surface draw style. Surface Mesh displays the mesh. Try out the other options on your own model. Under the Draw Style combo box are 4 checkboxes which allow to control if fringes, vectors, or contour lines should be displayed on the part, as well as if smooth shading should be applied. The workspace tree supports multiple part selection. All changes made in the Properties pane will then be applied to all selected parts. Here, we change the color of 2 parts at the same time. Finally, note that by default, picking in the view will also select parts and expose their properties for configuration. This video describes the use of the results item in the workspace feature tree. When you click on the results tree item in the workspace, the bottom pane displays all results and states found in the current model. Note that results are organized by type. There are tabs for scalar, vector, and displacement results. States may appear grouped, for example in load cases. Select the one you wish to focus on and then select the state to display. Results can be filtered. First, by nature. Here we select displacement, for example, or stress to limit the list. The full list is recovered by selecting Show All in the Filter combo box. Filtering on components is also possible. Here we show all results that are X components or magnitudes. Show All brings us back to the full list. There are checkboxes for each result in the list. Each one controls how the result will be displayed. The first one toggles the result visibility on the model. This will be as fringes for scalars, as vectors for vector results, and as a deformed model for displacement results. For scalars, a second checkbox controls visibility as contour lines. If the model has cutting planes, for example, a checkbox will be available for each result to toggle its display on the cutting plane. This video describes how to configure the display of scalar results on the model. When you click on the results tree item in the workspace, select the scalar result you want to display in the bottom pane. Upon selection, the result now appears under the Results Feature Tree item. Clicking on this new tree item displays all the available settings for scalar results in the bottom pane of the workspace. The first setting is the color scheme applied to the fringes. You are free to select among the wide variety of suggested schemes. Here, We show a number of these schemes and the effect on the display of the fringes. Toggle the Continuous Legend checkbox to get a smoother gradient in between fringes. Or else, you can adjust precisely the number of fringe levels to use. The range mode indicates how the min and max values of the scalar are computed. And if you would like to set your preferred values, choose the manual range mode and set them with the min and max sliders. By ticking the filtering checkbox, you can use the min and max value sliders to hide elements on which the scalar value is outside of the chosen range. The logarithmic scaling checkbox displays the scalar using a logarithmic scale. The node average checkbox displays the scalar at nodes regardless of the result mapping. The above, below, and undefined colors let you specify what colors should be used when scalar values are beyond the max value in the range, beneath the min value, or just simply not defined. This is illustrated by changing the range manually. The last two settings are valuable when the scalar is displayed using contour lines. Use them to define the number of lines and the mode used for the display. Finally, the bottom text box provides all the information Analyzer has on the selected result. This video describes how to configure the display of vector results on the model. Of course, a vector result can be shown at the same time as a scalar one, as shown here. When you click on the Results tree item in the workspace, select the vector result you want to display in the bottom pane. To gain access to the vector results display settings, just select it in the feature tree under Results. As with scalars, you can filter out vectors whose amplitudes are outside of a given min-max range. The length of the displayed vectors can be scaled by providing a scale factor. Toggling the relative checkbox indicates if the scaling is relative to the model dimensions or is an absolute value. Clamping can be toggled to impose the minimal and maximal length of the vectors. This is sometimes useful to improve visibility and nevertheless provide a good indication of the vector directions. You can also choose to color the arrows according to the current fringes used on the model, or as a single color. The single color is white by default, but can be changed. Vectors inside the model's volume can be shown using the Show Interior Vectors checkbox. They will only be visible with an appropriate draw style, like transparent surface or outline. This video describes how to configure the displacement result that will deflect the visualized model. Select the displacement result on the feature tree to view and edit its settings in the bottom pane of the workspace. A slider allows to scale the displacement and therefore increase or decrease the visualized deflection. The next two settings control the display of the undeformed model. First, you can specify its draw style, either lines or outline, or of course none, which means invisible. The second setting controls the undeformed model's color, which can follow the part color or use a custom color you specify. The text box at the bottom of the pane provides all the relevant information on the selected displacement result. This video deals with cutting plane definition and configuration in Ceetron Analyzer. Cutting planes are created, deleted, and selected in the feature tree. To add a cutting plane, click on the plus icon to the right of the cutting plane's tree item. This generates a default cutting plane and displays its properties in the bottom pane of the workspace. Use the slider to change the point in the cutting plane definition. You can also click on Pick to pick this point, or on the three dots to type in precise coordinates. The definition of the cutting plane normal can be done using one of the X, Y, or Z shortcut buttons. Use the INV button to invert the normal direction. You can also type in precise normal components in the text box beneath these buttons. A more interactive way to define the normal is to activate a locator in the view by pressing Shift and Control at the same time. The plane is then easily moved and rotated using the mouse in the view. The scalar combo box invites you to select which scalar result should be displayed with fringes on the cutting plane. The vector combo box does the same for vector results. You can adjust the density of the vector arrows using the grid spacing options and slider. Finally, you can choose an optional display of scalar contour lines in the Contour Lines combo box. The opacity of the cutting plane is easily controlled with the opacity slider. The checkboxes at the bottom of the Properties pane offer a wide variety of display options: clipping the model or not, show the cut plane surface or hide it, show the grid used for vector result display or not, enable or disable vector projection onto the cutting plane, show or hide the trace of the mesh resulting from the cutting operation, a coloring option, and a visibility option which allows to hide the contributions of invisible parts to the cutting plane. This video starts with an introduction to element set management in Ceetron Analyzer. We will see how to access the sets read in from the model, toggle their visibility, as well as how to generate new sets based on visibility. Other generation methods will be introduced in other tutorial videos. When you click on the element sets tree item in the feature tree, the bottom pane gives access to a variety of generation methods that will add new sets to your model. When you open the element sets tree item in the feature tree, all the sets in the model are displayed. If you have not generated sets, only the sets found in the model file are listed. You can toggle the visibility of each set either by double-clicking on the tree item or by clicking on its eye icon. Notice that if an all elements set is provided, you may wish to hide it when configuring the visibility of the other sets. A right-click on one of the element sets gives access to some shortcuts. Some handle visibility, and some are generation methods based on Boolean operations. A right-click on the element sets tree item in the feature tree gives access to shortcut features on the selected visible sets, such as showing their complement and removing or adding them all to the selection. We will use set visibility to illustrate the first generation method. Create a new set from all visible elements. This only requires pressing the Create button next to the visible generation method. Enter the new set's name in the text box and modify the default information if you wish. Then press Save. Your freshly created set appears in the feature tree now and is managed as any other one. Note the minus sign next to the item, which allows you to remove it. In this video, we will see how to create element sets using 2D Rubberband picking and 3D box selection. Click on the Element Sets tree item in the feature tree to access all the set generation methods. Let's create a new set using the Rubberband generator. Click on the Pick button and go to the view where a Rubberband selector is now active. Select the elements you wish to add to the group. The default behavior is to include elements whose nodes are all included in the Rubberband rectangle. The bottom pane of the workspace now allows you to name the set you just created, as well as provide some custom information if needed. Click Save and the element set will be registered in the feature tree along with all other sets. If the option to include partially contained elements in the set is checked, all elements that have at least one node within the Rubberband rectangle will be included. Let's move on to the next generator, which uses a 3D box locator to select the elements. Click on Show Box to display the selection box. If the Control key is held pressed, you can interact directly with the box by dragging the spheres at its corners to resize and simply panning the box itself to change its position. Click Create when you're happy with the box definition and a new set is generated, or click Reset Box to start from scratch. As previously, the workspace bottom pane now gives you the possibility to enter the set name and some custom comments. Press Save to register the new element set with the others in the feature tree. In this video, we will see how to create sets by filtering elements based on the value of a scalar result or based on the element type. Click on the Element Sets tree item in the feature tree to access all the set generation methods. Let's create a new set using the scalar result generator. Click on Scalar Filtering Setup to define the filtering parameters. In the filtering dialog, select the scalar result to filter on and specify the min and max values of a first range. Then add the range to the definition. Elements whose scalar value is within one of the defined ranges will be included in the set. When the result is mapped on nodes, the default behavior is to include elements if all nodal scalar values are within one of the ranges. An option allows to change that behavior and include elements if at least one node is within one of the ranges. When you are done with the filtering definition, click the Create button to generate the set. As for all set generators, the bottom pane of the workspace now provides text boxes to specify the new set's name and add custom comments if needed. Click Save to register the set in the feature tree. The final set generation method is based on element types. By clicking on Element Type Filter Setup, you open a dialog in which a list of checkboxes allows to specify the types of elements you wish to include in the set. Make your selection and click Create. Again, to register the set in the feature tree, specify its name and/or add a comment in the bottom pane of the workspace and click on Save. This video will show you how to add a history plot to your view. A history plot shows the evolution of a result at a fixed location when the model state changes. These plots are mostly used when studying a transient, time-dependent model. Adding history plots in Ceetron Analyzer is done interactively in the view. With the scalar result to plot displayed on the model, the first thing you need to do is select your preferred picking mode. This is done by right-clicking in the view. Next, you pick on the model the location at which you wish to plot the result. Note that the selection appears in the top pane of the selection window. Finally, right-click again in the view and select Add History Plot to create a new plot. The plot appears in the view in an overlay window and also in the feature tree under the Plots tree item. Note the minus sign button, which is what you would click to remove the plot. Plot configuration is dealt with in another tutorial. Back to the view. You can also add new curves to this plot using the same procedure. Pick a new location and then right-click in the view. You will see a new option, Add History to Current Plot. Add as many plots as you wish with Add History Plot, and as many curves to a plot with Add History to Current Plot. The plot windows can be panned within the view and also resized to configure the view to your needs. This video deals with the display properties of plots. When plots are created, they appear both in the view and as a tree item in the feature tree, which contains all the curves in the plot. To configure the looks of a given plot selected in the feature tree, the bottom pane of the workspace shows the current properties of the plot and invites you to modify them. Use the title text box to enter the title of your plot. You can also change the default axis titles. Show or hide the curve legend by toggling the checkbox. When Show Marker Line is checked, a vertical line is drawn in the plot at the current state. If an animation is running, the marker line will indicate where the current frame of the animation is on the plot. A slider lets you configure the opacity of the plot overlay window. The last two text boxes allow to precisely specify the width and height of the same window. Changes to properties, of course, apply to the plot selected in the feature tree. Note that the visibility of a plot is either controlled in the Properties pane by double-clicking on it in the tree, by clicking on the eye icon at its left, or finally through a right-click on the tree item. This is not shown here, but if you wish to configure a specific curve of the plot, simply select it in the feature tree and specify your preferred curve title and color. This video will show you how to generate a plot of a result along a line on the model. Creating such a length plot is done in the view. First, select how you wish to pick the locations that will build the line on the model. Right-click and choose your picking option. Before you start to specify the line for the length plot, make sure Multi-Select is checked in the selection window, as the line is defined by all the items you pick on the model. Now, pick on the model the locations that define the line along which the result is to be plotted. All picked items appear in the top pane of the selection window. With all the items selected, right-click in the view and choose New Length Plot All Items to generate a new plot and the curve of result values along the line. The plot appears in the view as an overlay window and as a tree item in the feature tree. Note the minus sign button in the tree, useful to remove the plot. As with every plot in Ceetron Analyzer, you can pan the window and resize it to configure the view. Result values are interpolated from one selected location to another, providing a nice smooth curve. Feel free to configure the plot or its curves in the bottom pane of the workspace. Another Ceetron Analyzer tutorial deals with this specifically. In this video, you will learn how to add annotations on your model. Annotations are graphical elements you can add to the view to display additional information, such as custom text, the length between 2 points, or the angle made by 3 points. On this model, you can see text annotations with element information that have been added by Ceetron Analyzer when picking the model. The procedure to add your own annotations is simple. In the feature tree, right-click on the annotations tree item and select the type of annotation you wish to add in the context menu. Let's take a look at text annotations first. Select the option in the context menu and then pick on the model the location at which the text needs to be displayed. A new annotation with default properties is created. There is no custom text and the scalar value at that point is displayed. Note the minus sign next to the annotations tree item. Click on this button to remove the annotation. In the workspace bottom pane, you can now configure the new annotation. Add your custom text in the label text box. Hide or show the scalar value, toggle the annotation's visibility, or change its location. A distance annotation is added very much in the same way. Right-click on the annotation's feature tree item and select Add Distance. Then go to the view and pick the 2 points whose distance needs to be measured. The annotation is displayed and its properties are available for modification in the workspace bottom pane. You can add a custom text, change the point positions, or toggle the visibility of the annotation. Follow the same path to add an angle annotation. This time you pick the 3 points that form the angle on the model. Add a custom text, change the points or the annotation's visibility in the bottom pane of the workspace. This video introduces an interesting feature of Ceetron Analyzer, situations. This is what we call the set of properties used to fully configure the display of the model. They include, for example, part settings, the current scalar result, the current vector result, any cutting planes or isosurface or isovolumes, overlay plots, view background, view position, etc. All these properties can be stored as a situation when working with a source model. There are 2 interests in doing this: reapplying the situations on the same model in another working session, and applying the situations on other similar target models, which is very useful when post-processing similar variations of the same model. Clicking on the Situations tree item brings up an information text and situation management buttons in the workspace bottom pane. The text is self-explanatory. Use the buttons to clear all stored situations export all of them, or import all of them to and from an archive. Let's create a new situation. First, we configure the view, setting the properties we wish to store in the situation. In this example, we choose to display the X displacement on the second load case and at time t equals 2 seconds. Going back to the workspace, the situation is created by clicking on the plus sign next to the situation's feature tree item. The situation is inserted in the feature tree in a folder named as the source model, and its properties appear in the workspace bottom pane, where you can adjust the default values. Note that a snapshot image has been taken for easier identification. You can change the situation name and click Save to record your changes. Situations are attached to their source model and appear as such in the feature tree. When we close and reopen the current model, we can jump to a given situation quite easily. Select the situation you wish to recover. It appears in the workspace bottom pane. Then simply click on the Apply button to get back to work where you left it. And you can store multiple situations to easily browse through your preferred post-processing configurations. This video will show how to export situations to an archive you can share with others, who can then import the situations for their post-processing purposes. Situations are an important feature of Ceetron Analyzer. If you have not yet done so, we suggest you view the first video on the subject to get a better understanding of what situations are and how to produce and use them. Situations appear in the feature tree under the Situations item, and then in a folder named like the source model used to create them. If you right-click on one of these model folders, you will see the export and import options. Choosing to export the model situation opens a dialog in which you can cherry-pick the situations that will be stored in the archive. Select those of interest, click Export, and choose the archive file before pressing Save. The post-processing situations can now be shared with other users. To illustrate the import of situations from a shared archive, we first delete them from this workspace. We then reopen the model, mimicking a different user. To import the shared situations, select the option by right-clicking on the Situations feature tree item and selecting the appropriate option. Find your preferred situation archive file and click Open. The situations are added in the feature tree, and the new user has instant access to them for a more efficient working session.